Hi everyone! This video is going to go through the steps of conducting an ANOVA in which you have one independent variable that is between groups and one independent variable that is within groups. We'll start off with a new notebook. We'll get rid of all the template code. We'll call this the between and within ANOVA R notebook. And what we'll do is, just like with the last video, we'll start at this web page here, and we'll follow along with the steps outlined in the How to Run Type 3 Sum of Squares ANOVA in our tutorial. First, we'll install the packages that we need to run the ANOVA. So first we need the package that allows us to import the SPSS files. Then we need a package called tidyverse, which helps us clean up our data and reshape it so that it can be analyzed by R. So we'll say this teaches R how to clean and reshape data. And then we need the package that allows us to run the ANOVA with the type 3 sum of squares. And that's called AFEX. Going to run those now. We get some information about those packages. I'm going to run it again just to get rid of those warnings. All right, so next we want to import the data. So I'll make a section called import data. I'll make a new R chunk. And as before, we will save the data into a variable called dataset, and we'll use the read_sav function of the Haven package to do this. And again, this is a data set that I have on an Open Science Framework project. I'll press play. See the environment is now updated with 715 observations. But now we need to tidy the data up so that we can analyze it with AFEX. And so we're going to use the tidyverse to do that. So I'm going to call this next section tidying the data. Make a new R chunk. We're going to start with dataset, and we're going to pipe that into the distinct command to remove the duplicate rows. So we're going to check if there are any duplicate subjects, and we're going to tell R to keep all of the rows that are unique. And we're going to save that into a dataset called dataset.unique. I'm going to press play. And now you can see that whereas originally there were 715 observations, now there's 714 because one participant was listed twice. I'm just going to put a comment here saying remove duplicate participants. And what I'm going to do now is I'm going to go to the console and I'm going to type view dataset.unique. And now we can take a look at our data. There are 6 variables. One of them is the ID variable, that's subject. 3 of them are between groups independent variables. So training type refers to whether the training was focused on changing attitudes or changing identification. EC refers to the goal of the training. So was the goal of the training to reduce bias, or was it to maintain bias? And IAT order refers to which of the dependent variables, race D or ident D, participants completed first. So for some participants, they completed the attitude IAT first and then the identity IAT. And for other participants, they completed the identity IAT first and then the attitude IAT. We are going to interpret these two dependent variables as it are within a repeated measures framework. So we're going to argue that because race DFAB measures implicit prejudice and IDEN DFAB measures implicit identification, they are two flavors of implicit responses. And so the first flavor of implicit response is implicit prejudice, and the second flavor of implicit response is implicit identification. And we're going to treat them as a within groups variable. Now, to do that, we need to reshape our data from wide to long. Now, a wide format means that every variable gets its own column. And in a long format, all of the responses are in the same column. So right now, both of our dependent variables are in their own column. When we reshape this data set from wide to long, what'll happen is all of these numbers will be in one column, but each participant will have two rows. So 12 rows, 3, 3, 3. She will have two rows. In the first row, there will be the value for the implicit prejudice score. In the second row, we'll see the value for the attitude IAT score, or sorry, for the identification IAT score. So let's reshape the data, and then we'll come back and take a look at what the long version of this data set looks like. All right, so I'm going to call this, I'm going to make a new chunk. I'm going to comment here that what I'm doing here is reshaping the data from wide to long. So I'm going to start with dataset.unique, and I'm going to pipe that into the function called gather. First, I'm going to this write down what I think is a good name for the within groups variable. So I'm going to call it implicit bias. And I think this is a good name for it because our two dependent variables could arguably be different flavors of implicit bias. So the first flavor could be implicit prejudice, and the second flavor could be implicit identification. The next argument I send to the gather function is what I think is a good name for the value of responses, and I think value is just a good name for that. The next step is to tell gather which variables are not related to our dependent variable or our within groups variable. And so in our case, all of the identification, so the identification variable, subject, as well as all of the independent or between groups variables are not part of our within groups variable. So we're just going to tell gather that. We're going to put a minus sign and then the names of those variables. So don't include subjects in this function. Don't include train type. Don't include EC. And don't include IAT order. And then we're going to assign the output of that function to a variable called dataset.unique.long. And that just tells us that this is the it's a dataset, only unique values, and it's the long shape instead of the wide shape. And when I press play, hopefully there's no errors. Looking like no errors. And what we're going to do is look at that dataset. So first, in the environment, we can see that dataset.unique.long has exactly twice as many observations as dataset.unique. That's because each subject in dataset.unique now has two rows, And if we look at dataset.unique.long, and we sort by subject, we can see that each person is getting 2 rows. So 01 Azalea 646 has 2 rows. The first row describes her implicit prejudice score, and the second row describes her implicit identification score. And that's how it is for every single participant. So we now have our data in long format. And now we can perform the ANOVA. So I'm going to call this section the 2 by 2 ANOVA, 1 between factor, 1 within factor. Going to insert a new chunk of our code. And this code is going to be almost identical to the code that we use for the between subjects ANOVA. There's only going to be one addition to the code. So I'm going to call this dataset.unique.repeated measures. I'm going to assign it the value of AOV easy, which is a function from the affix package, which makes ANOVAs easy. First, we tell this function what the ID variable is, so that's subject. Then we tell it what the DV is, so that's value. Then we tell it what the dataset is. So in this case, our dataset is dataset.unique.long. Then we tell it what the between groups variables are. In this case, I'm going to choose for my between groups variables the variable that describes the goal of the training. So whether the training was to reduce bias or to maintain bias, and that's EC. And then I'm going to tell easy ANOVA what the within groups variable is. And in that case, it's implicit bias. And so just to review where all of these names of the variables came from, I'm going to look back at dataset.unique.long. So we can see subject is the ID variable. EC refers to the type of training, to reduce bias or to maintain it. Implicit bias refers to is the within groups variable, right? So the values are either race D or ident D for every participant. And value is the dependent variable, right? That's where the actual scores are. And so that's where all that information about what to put into this command came from. We just grabbed it from the names of the variables in that in our data set. All right, so I'm going to press play. Visually, nothing happens. But in the environment, we can now see that there is a variable called dataset.unique.rm. And if we want to look at it, we can type dataset.unique.rm, press play again. And we can now see our ANOVA table. Now this ANOVA table is telling us 3 pieces of information. It's telling us that the main effect of training goal is significant. It's telling us that the main effect of implicit bias is also significant, but it's telling us that the interaction between our 2 independent variables is not significant. So that means we need to determine the meaning of these main effects. So for example, when we see that the main effect of training goal was significant, hopefully that means that participants that were trained to reduce bias had less prejudice, right? But maybe that's not the case. So we've got to check. And we can do that with the tidyverse. So I'm going to make a new section called means and, let's say standard deviations for the main effects, and I will make a new R chunk. I will start with dataset dot unique dot long, because this is the dataset that has the raw scores that we can analyze, that we can get the means and standard deviations from. And I'm going to pipe that into the group by function. And I'm going to group by, first we'll do the main effect of EC, or training goal. So I'm going to group by EC. I'm going to pipe, and what that does is it just splits the file, like what happened in SPSS if you use the split file command. And then I'm going to use the summarize command to calculate the mean for the two groups of EC. And so that's just going to equal the mean of value. And we'll also get the SD of value. And so we can see that in the reduced bias condition, scores are lower than in the maintained bias condition. So I'll make a little comment here that first we calculate the means and SDs for the EC main effect. And now we'll do the exact same thing for the implicit bias main effect. I'm going to press play. And now we can see that scores for the identification IAT were lower than scores for the prejudice IAT. All right, and so the code on the screen now is all it takes to run a 2x2 ANOVA with one between factor and one within factor.